Hi everyone, welcome to the Bioreactor Design Analysis problem solving session for week 3. So let's start with the questions. This week we'll be mostly having just numericals. So I hope you have a pen and paper and a calculator near you. So let's see what the first question is. So the question number 1 is 7 uh, chlortetracycline is produced by high cell density cultivation of a engineered strain of Streptomyces aureofaciens in fed batch mode. Right? Fed batch mode, as you know, is where media will be added to the culture at constant intervals, right? Uh, with intermittent addition of fructose solutions to the culture medium. The initial culture volume at quasi-steady state, that is V, is equal to 300 liters. And fructose containing nutrient solution is added at a flow rate of 100 liters per hour. So every hour you will add 100 liters of fructose. Fructose concentration in the feed solution and the initial cell concentration is given as S naught equals to 400 gram per liter. That is the fructose concentration in the feed solution. Okay. And the initial cell concentration X naught is 15 grams dry weight by liter, right? So you have to assume that the organism follows Monod's kinetics, and the kinetic and yield coefficients of the organism are given by mu max equals to zero point 0.2 per hour, Ks equals to zero point 0.5 gram per liter, and uh, yield coefficient equals to zero point 0.3 gram dry weight by gram fructose, right? So you have to determine the cell culture volume at quasi steady state when time equals to 5 hours. So 5 hours have passed since you have started your culture. Okay, so you have to find out the culture volume, and this is a relatively easy question. So you know you started off, wait, let me just use the pointer. Okay, so you started off with the initial volume of 300 liters, right? And each hour you will add 100 liters due to it being a fed batch. So the time given to you is 5 hours, right? So after 5 hours you have 500, right, liters plus the initial 300. So you have 800 liters, right, of media or culture volume at quasi steady state. So, if you want to do it using a formula, the final volume is equal to the initial volume plus flow rate into time, right? So, initial volume is 300, flow rate is 100 into time, which is 5 hours, will give you 800. Okay. So, this is a very easy question. So, you just have to think about it a little. So, since there are no doubts, I will move on to the next question. So you have to find the dilution rate after 5 hours of this fed batch operation. Okay. And the answer has to be in R minus 1. Okay. So let's see initially what you have. Flow rate is given in R. So that is not a problem. Um, so you know the dilution rate is given by the flow rate by volume, right? So to ensure that you have it in R minus 1, you have to see in what units flow rate is given to you. Flow rate is also given to you in liters per hour, right? So that is okay. So you don't have to do any conversion here. So you know the flow rate is 100 and you know the final volume is 800. So you know if you divide that, you will get the answer of 0.125 per hour. So that is the dilution rate, right? So let's see the next question. So you have to determine the concentration of fructose at time equals to t equals to 5, and that is the quasi steady state. Okay, in gram per liter. The answer has to be gram per liter. So you know that under quasi steady state, your dilution rate is equal to your growth rate. Okay. So according to Monod's kinetics, the growth rate is given by this formula mu max S plus mu max S by Ks plus S, right? Where S is the substrate concentration. Okay. And at quasi steady state, you know the growth rate equals to the dilution rate, right? So if you use what you have to find in this case is S, the concentration of fructose. That is the concentration of substrate, right? And you know dilution rate, you know mu max, you know Ks, because both of these things have been given to you in Ks is there, mu max is there, right? Have been given to you in the question itself. So if you rearrange this part of the equation, the D equals to mu max S by Ks plus S, if you rearrange it so that you get S out, you will get this formula. The dKs by mu max minus D, right? So you can just input in the values, which is 0.125 per hour into zero point 0.5 gram per liter, which is the Ks, divided by mu max, which is zero point 0.2 R minus 1 minus 0.125 R minus 1, which is D that you have just found out here, right? And you have to check if you have to do any conversion for you to get the answer in gram per liter. So let's see, this R minus 1 will be cancelled, this R minus 1 will be cancelled, right? And like this R minus 1 and these two R minus 1 will be cancelled, right? So what you will be left here with is with the answer will be in gram per liter. Okay, this is the only thing that is not being cancelled, right? And that is the answer you need also. So that is fine. So once you calculate this, you will get an answer of 0.823 gram per liter. Okay, let's move on to the next question. So you have to determine the total amount of cells at quasi steady state, which is again at t equals to 5 hours, and the answer has to be in kgs. Okay, so you know at quasi steady state and at high cell density that the substrate concentration is much less than the initial substrate concentration. Okay, and also you can apply that fact that the dilution rate will be equal to the growth rate at quasi steady state in the mass balance equation. Okay, so the total amount of biomass is equal to the amount of biomass at time t equals to 0 plus the yield coefficient, the initial substrate, and flow rate into time, right? And you know that initial biomass is equal to at time t is equal to x naught into v naught, right? So you have to now input the values, right? So you know the uh, you have expanded this x uh, t x naught t, right? So you have expanded that. Okay, so x naught is the initial cell weight which is given to you into the initial volume, which is 300, plus the yield coefficient 0.3, okay, into the initial substrate rate, right, 400, into the flow rate, which is 100, right, into time, which is 5 hours. So you get an answer of 64.5 kg. Okay, in this case you would have gotten your answer in gram, right? And you will have to convert that into kg. So to convert gram into kg, you will have to divide by 1000, right? So you'll have to divide the answer by 1000 to get uh, the answer in kg. So let's move on to the next question. You have to determine the concentration of cell at quasi steady state when time equals to 5 hours again. So concentration of cell X is equal to xt by V. Okay, xt is the total amount of biomass at the end. Okay, so that is 64.5 kg by 800 liters. Okay, so since you're finding the total amount of cell mass here in kgs in the 800 liter of cell culture media, you're finding gram per liter here, right? You're finding gram per liter. So since you have total amount of 800 liters and the total amount of cell at the end of the culture is or at quasi steady state, which is 64.5, So if we divide that, you will get an answer of 80.625 gram per liter of cells are there. Okay. Now let's move on to the next question. So if the specific product formation rate is given as 0.05 gram product per gram cell, okay, and P naught, which is the initial product concentration, is 0.1 gram per liter. You have to determine the product concentration in the vessel at time equals to T equals to 5 hours in gram per liter. Okay. So, like we had done in this question where you had the mass balance equation for the biomass, we have the mass balance equation for product. Okay. So, product is equal to P naught into V naught by V, P naught being the initial product, V naught being the initial volume, and V being the final volume. Okay. QP is the specific product formation rate, XM is the amount of cells, right? V naught is again the initial volume, V is the final volume, dt is the dilution rate into time by 2, and T is the time. Okay, so uh, let's see. So you have to XM, you know, is y-axis by S1. Okay, so you have expanded this XM, the amount of cells, right? Based on the yield coefficient and the initial substrate. Okay, so let's now add the values. So P equals to uh, P naught, which is the initial product rate, is 0.1. Okay, that is given to you here, 0.1 into initial volume 300 by final volume 800. Okay, plus QP, which is given as 0.05 into initial, sorry, the yield coefficient, which is 0.3 into the initial substrate, which is 400. Okay, by 300, which is the initial volume, by final 800 volume, plus the dt, which is 0.125 into 5 by 2, and this entire thing divided by multiplied by 5 hours. So once you calculate this, you will get an answer of 20.66 gram per liter. Okay, so that is the product concentration in the vessel at time equals to 5 hours. Okay, so that is it for questions regarding week number 5 for our case. I hope you understood. Okay, thank you.